Very good morning class. Welcome to 8th semester. In this semester we are going to discuss a professional elective non-destructive testing. Let us see what is non-destructive testing and why we are going for non-destructive testing. So for example, if you want to see any kind of material which has to be tested, initially we use two different techniques. For example, if you want to test tender coconut, you will try to check it by using tapping on it. Similarly, if you want to test walnut, or if you want to test badam seeds, then you will try to bite it and you will try to taste it. Similarly, the materials will also be tested by using two techniques, that is, one is destructive and another is the non-destructive techniques. So first of all, let us see what is the syllabus, how it covers, and then we will see the introduction part of the non-destructive testing in our lecture 1 of this subject. So the syllabus goes like this. The first unit deals with liquid penetration inspection techniques. In this, how the inspection is going to be done on the materials, what is the principle behind it, what is the characteristics, what type of liquids can be used and what type of solvents can be used on the material, and what surface treatment is required for such type of material. Along with that, we will try to see some magnetic property instructions, like how by using what kind of techniques that can be done on for a magnetic materials like ferrous materials. Second is eddy current testing. Most of these things are different types of non-destructive testing itself. The main advantage of this is this can be done on the same material, different tests can be carried out. Okay. Second unit deals with eddy current testings. So we will see the what is the principle, how it is going to be carried out, and how we are going to check where the flaws are present in the material. Next is ultrasonic testing by using some kind of ultrasonic waves or beams, how the material is going to be tested. So that completely deals with your unit 3, and your unit 4 is radiography. Radiography, generally in this we say just like your x-rays, you will pass the x-rays and you can see your bone fractures. Similarly, you can go for ultrascan and you can see the any cancer tumors inside the body. Similarly, the radiography can be done on a material, so that we can see what are the flaws present in the material, what are the extra materials existing inside the material that can be observed. Next is the final thing is acoustic emission. That is nothing but when the material is exposed for such kind of stresses and bendings, so you can observe that there will be some kind of sounds or emissions that can be done on it. So basing on the emissions, how the flaws are present in the material, how that can be detected, how what are the techniques, what are the methodology, that we are going to see. So among these things, if you see, all of the materials can be done only by using without destructing the material. So first of all, let us see what is non-destructive testing. So it is a process of inspecting, testing, or evaluating a material. Okay. So generally, if you want to test a material, generally if you see some material, if it is a good or not. For example, I have told an example of a tender coconut. If you want to see that the coconut is good or not, so we will try to tap it, or you will try to shake it and see if the water content is more in the tender coconut or not. Similarly, if you go for buying of a lady's finger, if you might have observed the ladies that they will try to break the tips of the lady's finger, so that they can assume that is the lady's finger is a good one or a bad one. Similarly, if you see some of the fruits like tomatoes, like mangoes, when they are buying, they try to press it, so that we can understand the material is good one or not. Similarly, in inspecting the material, we use some technique that is non-destructive technique. It is done for evaluating the material, testing the material, inspecting the material. The main advantage of this is it will in this process we can able to identify the discontinuities or the what was the effects without destroying this serviceability of the material. For example, if you are using a material in some part, for example, you are using a connecting rod in your automobile. Suddenly you got a thought that is the connecting rod which I am using is a good one or not. So by using a non-destructive testing, you can measure, you can able to check is there any flaws in the connecting rod or not by directly when it is in a service itself. That is the most advantage of a non-destructive testing. If you want to test that without non-destructive testing, then you have to take out of that what we say connecting rod from your automobile, and you have to go for different kinds of tests, like its hardness test, then it's for its impact test, then different type of test needs to be carried out only when it is taken out. So once the destructive testing is carried out on the material will be wasted. Again you have to make a new material. So, but whereas in non-destructive testing that is not the case. Once you even though it is in a service, you can be able to perform a task. After finding the flaw, if it is not a good one, you have to remove. If it is a good one, you can proceed with that. Okay. So the non-destructive testing is an examination that is performed on an object of any type. So it can be done on any type, size, shape of or any type of material to determine the presence of discontinuity. Discontinuous might be like flaws, like holes, like extra material or anything, to evaluate the other material characteristics. So what is the main objective is material sorting, how the materials are sorted, what are the characteristics, so how the properties are to be monitored. For example, and the material which you are using in like magnetic properties you can be measuring. If you say similarly like using SEM analysis, you can see some of the what we say heat affected zones can be absorbed. So such kind of properties can be monitored using non-destructive testing. Thickness measurement, this is also one of the thing. If you have made a hollow shell, if the hollow shell, sometimes if the hollow shell is a too small one, you cannot use a vernier caliper or something else to measure the thickness of the layer. So that can be done by using a non-destructive testing method. Okay, next is defect detections. Next is defect characterization. What is the defect present and what type of defect can be characterized easily. Next, what are the uses is flaw detection, evaluation. So once you have detected the flaw, and you can evaluate what kind of flaw is this, how far the flaw is present. So this thing. Leak detection. If for example, if you are continuously using some kind of pipe, you don't know where the leakage is happening, because if you can see generally in what we say drainage system itself, the drainage system is a underground drainage system. You cannot see where the water is got leakage and where water is coming out from your drainage tank. Okay, so to identify it, you have to dig the whole pipeline again. You have to see where it is damaged. You have to check from one step to another step, then you have to cover it. So until unless you find the flaw, you have to completely dig the whole pipeline and you have to remove it. So but whereas in this it is not required. This is mostly used in if you say underground petrol. You can see that the petrol is being transported from Gulf countries to India. So such kind of pipelines are undergrounded. They are huge pipelines. So for them again to dig back the whole pipe, to check the flaw, again to keep the pipe. So it is a hectic process for us. So in such kind of things, what we can do is we can use some kind of non-destructive testing methods from the outside of the sources itself. For example, from the outside the earth itself. For example, if your whole petrol tank pipeline is going under beneath the ocean layer, from the outside the ocean itself you can send some high frequency rays which passes through the water and even passes through the pipe, basing upon the reflection of the what we say acoustic waves, or by using the ultrasonic beam, which what it is reflected back by the way it is getting reflected back, you can able to identify the leakages in the pipeline. Next is location measurement. Yeah, this is also the thing where the exact location of the pipeline is there. For example, if you see that in roads, generally we observe that there will be two pipelines. One is drainage pipeline, another is for current pipelines. For current transportation, there will be another pipeline. So if you are a person who's doing different works, GHMC is a different task, electrical department is a different task. Both did not combine with one when they are doing a work. So what they do is, they before planting their electric lines inside the earth, they will try to find where exactly the pipeline goes. Okay, until unless they don't know where the pipeline is going, they cannot dig. Similarly, to identify where the pipeline exactly goes, they have to use some technique. They need not to dig the whole earth again. They have to check. Yeah, the pipeline goes this way. We have decided we have to go for the electric line. That doesn't happen. They just able to find it without digging. So that can be done by using an NDT technique. Next is dimensional measurement. I have told an example of dimensional measurement. If the small thicknesses are there which cannot be measured using any kind of micrometers, that can be done by using a non-destructive testing methods. Next is structure and microstructure. I have told an example of SEM analysis. Similarly, by using for example like X-rays also, you can see that where the bone is fractured, how much length the bone is fractured. Similarly, the material, how the material is broken, what is the structure of material, in what way it has failed. So that things can be observed using a non-destructive testing. Next is stress strain and dynamic responses. So for example, your rod is under operation. I have told an example of piston rod or a connecting rod which is connected to your engine already, your automobile already. So while it is performing a task, so you can send some kind of waves or some kind of rays, and from the outside, the during its operation itself, when it is in a stationary condition, how it is behaving, when it is operating, what is the kind of responses we are going to observe. Just like in ANSYS we can do that, can be observed. Next is material sorting. We can identify the various types of metals, like material, is it a metal or a non-metal, is it a ceramic or a composite. That can also be identified by using a non-destructive testing method. Next is chemical compositions can also be determined by using a non-destructive testing method. So let us see what are the material properties which you can be measured by using a non-destructive testing. That is, by physical properties we can observe the color, density, melting point. These are the physical properties. For example, chemical properties like corrosion resistance, atomic weight, equivalent weight, valency, these can be measured. Like mechanical properties, we can be able to measure strength, elasticity, plasticity, ductility, brittleness, hardness. These are all can be measured by using an NDT technique. Similarly, electrical properties like resistivity, conductivity, capacitance, dielectric properties, so these also can be measured. Magnetic properties like relative permeability, relativity, retentivity, susceptibility, hysteresis, this can be measured. Whereas in thermal properties, specific heat of the material, thermal capability, thermal conductivity, so these can be done on a similar material or different materials can be done. Okay, all the operations can be done on a particular same kind of material at a time, or a different techniques can be used. Next, technological properties like malleability, machinability, weldability, castability, formability. Next is aesthetic properties from its appearance, texture, and ability to accept the special finishes. Economic properties like raw material, in raw material how it is behaving and what is the processing cost for it. Other properties like optical properties, acoustic properties, physiochemical properties can be studied. So if you, for example, if you want to measure the material properties, so we can go for two types of testing. One is destructive testing, another is non-destructive testing. So in destructive testing, generally we go for a tensile testing, ISAR testing, hardness testing. In all this destructive testing, what we do is we go for an tensile application on a load. After application of the tensile load, the specimen will break. So at what load it is breaking, basing on that we can able to understand the maximum tensile load of the material. So what is happening here, your load, your material which you are going to use, first initially you have to make a specimen of it, you have to apply the load, you have to break it. So once the material is broken, we cannot use it again. So that is the main disadvantage of destructive testing. Next is ISAR test. Similarly in ISAR chart plate test which we do for impact testing method. So if you see that the load is going to be impacted on the material, that is also for that we have to make a particular specimen as per ASTM. Okay, so according to that only we can able to test the material. Next is hardness test, Grinnell hardness test, Wicker hardness test, Rockwell hardness test, any kind of test you take. So in all this test, once the material gets deformed, it is of no use for us. Again, by seeing that we can able to make the same material for that particular load, that's it. But the part which is broken or which has been used in the test cannot be reused for any kind of purpose. Similarly, but whereas in non-destructive testing, the part which is used in the testing can be used in your applications. Okay, that is the main difference between the destructive testing and non-destructive. So if you see what are the various types of non-destructive testing, first is visual inspection method. By seeing itself, for example, if you are having some cotton boxes, so by the way it is seeing, we can able to visualize. The example I can give is by seeing the rice. Most people like touching the rice and seeing the rice, they can able to visualize, is this a old rice or a new rice. So by just visualizing the part, we can able to understand the part is a good one or it is a failure part. Just like sampling techniques, we can use that. Next is liquid penetrate technique. That is by using some kind of liquid, what we do is we view the liquid on the surface, basing on the way the liquid is behaving, and it is giving some, what we say, the responses. Basing on that we can able to understand if the material is a flaw one or a good one. Next is magnetic particle testing. Magnetic particle is nothing but we send the particle magnetization to it. That is nothing but paramagnetism will be done to the material. Basing upon the current passage, what happens is the arrangement of what we say inside the atoms, the arrangement will be differ from flaw section to the normal section. Basing on that deviation, we can able to understand the flaw part is which is a flaw part, which is a good part. Next is thermographical testing. In thermographical testing, we generally send some kind of thermal responses. That is nothing but temperature changes. Next is eddy current. Again in eddy current we will try to send some kind of current through any circuit. Basing on that you can able to get some electromagnetic field. So the way the electromagnetic field is behaving around a material, then basing on that we can able to analyze. Next is ultrasonic testing. In ultrasonic testing we generally send some ultrasonic beams. Next is acoustic testing. Acoustic testing is nothing but some kind of sounds which we are going to observe. So these all testings we are going to see first, because these are the basic techniques among the non-destructive testing techniques. Among these we are going to see all the techniques in your 5 units, but they have been distributed in different units. The first thing, that is visual inspections, they have not provided for you, because it does not come in generally does not come in a non-destructive testing, because visual inspection does not require any kind of technology or any kind of thing. It just depends upon the person who is going to visualize it. Okay, so other than those things, that is liquid penetration, magnetic, thermo, eddy current, ultrasonic, acoustic, all these you have in your whole 5 units. So before entering into those units, let us go through all the techniques, what is the principle behind that. Then we will go into the advantages, disadvantages, what are the various characteristics of the various techniques. Okay, so visual inspection. Visual inspection is commonly defined as the examination of a material, component or a product for conditions of non-conferencing using a light and eye alone or in conjunction. That is nothing but you just pass a light. Just for example, you can see optical microscope you might have used in testing the material in MMS lab. So in that just we are passing a current, passing a light, and we are observing under a microscope, and you can able to see the distribution of the grains inside the material. And basing upon the grains distribution, we can able to analyze the material is a good one or a bad one, how much strength it can withstand. So we can able to analyze to some extent. Okay. Another thing is here we are using both that is light, that is microscope, okay, metallurgical microscope, as well as the eyes. Instead of that, if you are using only eyes, just by observing, if you can able to say that the material is a good one or not, that is a visual inspection. Next is liquid penetrating testing. In this liquid penetrating testing is one of the effective methods of detecting the surface defects in a material. Just clearly sees that we can able to only analyze the liquid defects, that is nothing but surface defects in metals and non-porous materials. Especially it can be, this method is used only for the surface techniques. Okay, it cannot be go deep into the material. If the flaw is present inside in the deeper layers of the material, you cannot able to understand, you cannot able to study by using a liquid penetrating testings. Okay, it is mostly applicable only to the surface techniques. Okay, next the principle behind this is the principle is that the liquid penetrates are drawn into the surface loss such as cracks and porosities by capillary action. Then the developer material in the conjunction with the visual inspection reveals the surface loss. The best technique I can simply explain this is, for example, if you are having a surface which is having some kind of holes. So the best example I can give for this is the tire puncture. So for example, if your two-wheeler tire is a punctured one, so you cannot able to see with your naked eye where the tire is punctured. So what the puncher man does is, if you take it to a puncture shop, so he will give the he will fill the tire. He will try to give some amount of water it. So because of porosity or because of capillarity effect, where the air is coming out, at that part will be showing some kind of bubbles. So basing on that, he will understand that how many punctures are there in your tube. Similarly, on a material, if there is some kind of any flaws, if you are applying some kind of liquids, so there are different types of liquid, we will see all those things next. So when you apply some kind of liquids, so where there are flaws, where there are some small cracks, what happens, the liquid will try to go inside, okay, or it will create some kind of projections at that surface. So basing on that, we can able to understand that there is a flaw at that particular section. Next is magnetic particle testing. So in this magnetic particle testing, most probably we will go for ferromagnetic properties only. Ceramics cannot be done on this, because ceramics are not good conductors of electricity or magnetic properties. So when they are magnetized, they will be having a distorted magnetic field in the vicinity of flaws. So for example, if you see, we might have studied in 12th class, that is when a magnet is brought near, for example, there is a permanent magnet, around it if you are bringing a magnet, what happens, there will be some flow of magnetic lines around the material that can be analyzed by passing a different needle around it. So if suddenly some other flaws or some other distortion is happening, means there is some kind of misarrangement of magnetic properties around that section. That can be understood by using this technique. Okay. Next is thermographical testing. In this principle, the main thing is what we do is we try to map the thermal inspection. That is nothing but we will pass the temperature and how the temperature is going to flow from one to end another surface, or from one section to the other section, or on the surface how it is going to vary. That we will try to graph on a particular thing, and basing on the graph we will try to able to understand where, because if there is some kind of flaw, what happens means there will be the temperature difference can be easily observed from one layer to the other layer. That temperature difference, for example, you take some kind of material which is having a small hole in it. So if you see that the temperature at the surface and the bottom surface will be different one, and at the center it will be different because of that what we say hole or crack, the temperature will be a different case. So basing on that we can able to understand where the cracks are present. Okay. Next is eddy current testing. When eddy current testing is induced, the test object is brought near to a alternating current source. That is nothing but AC current sources. The eddy current is generally parallel to that of the winding. For example, if you see most of the what we say paramagnetic substances, you are going to magnetize by your side, but that is by sending some kind of AC current through a material. What we can do is we can make an artificial magnet. So if you see the artificial magnet, the magnetism will be parallel to that of the winding. In which way you are giving the winding, basing on that winding the eddy current will be generated. Eddy current is nothing but the opposition to the current which you are passing. Okay. So both will be parallel to one another most of the time. So because of the defects, what the direction is, the direction of the current generated will be in a different direction. There will be a change in the direction. Basing on that there will be a damage of electromagnetic field which is generated around the materials. Okay. So basing on the variation how the electromagnetic field is varying, that we can be observed, and basing on that we can say the material is a flaw one or a good one. Okay. If it is a good one, it will give the proper electromagnetic field. If it is not a proper one, it will give a different kind of electromagnetic field. Next is ultrasonic testing. In ultrasonic testing, we generally send electron beam through a test object. You can take the pipelines. So when the when the ultrasonic beam is passing through it, if there is some internal flaws, what happens means, because of that internal flaws there will be small gap created. So because of that small gap, the upper surface will be reflecting the ultrasonic beam first, then the layer which is below it, that will be reflecting back the the electrosonic beam. So basing upon the reflection and the amount of the time which it has taken for the reflection, we can able to, and the amplitude, that is also important, how much amplitude. This is generally used in your radar techniques. For example, if your flight is going, you will send some signals to the aircraft. Basing upon the time of reflection of your signals, you can able to understand how far the aircraft is from you. The radar techniques all works on the same technique. Okay, clear? Next is acoustic emissions. In this, almost all the materials will emit high frequency sounds when they are stressed. Okay, when they are stressed, when they are deformed or undergoing structural changes. These emissions can be detected and provided the induction of dynamic changes within the material. So with this we stop the basic things of your first lecture of our NDT. So this is the main these are the main techniques which we are going to discuss in your whole NDT syllabus. So I just wanted to give some kind of introduction to the NDT, why we are going for NDT, what is the need of NDT, why we should not use destructive testings. Sometimes it is important you should go for a destructive testing if you have a specimens. Generally if you are making for a large scale, which is already if you are going to make a new part, okay, if you are going to make a new part, for example if you are going to make a composite, so it is good if you go for a destructive testing, because basing on that only you can able to understand where it is failure. Once you are making a part, you are going to install the part into the system. At that time if it is suddenly fails means it will create a large amount of loss. But sometimes if because of repeated application of load, just like fluctuating stresses, or because of fatigue, the material may fail. So these kind of things can be studied by using a non-destructive testing, so that you should have a clear picture. So what is the importance of destructive testing, what is the importance of non-destructive testing. So for a new material, or for a we have some specimen, then we go for destructive testing. If it is a real life application where you are continuously using some kind of things where it requires especially in non-destructive testing, the skilled employer will be a must, because the skilled employer will only able to understand these things, that what is ultrasonic testing, what is eddy current testing, what is so that the person's skill will be too much. So he should able to understand how the behavior. For example, when I told that there is a, in this if you can see, the electromagnetic field direction changes. So these changes in the direction, a normal man cannot be able to understand. If this has to be understood by some experts, the skilled persons can only be able to understand, because that is the reason non-destructive testing may be initially a huge investment compared to that of the destructive testing, but in real life application non-destructive testing will be useful when the part is already in use. Okay, if you are before application, before getting into the use, if you are going to do testing, then it is non-destructive testing is good. After applying into some application, if you are going to test, then it is non-destructive. But whereas in this, the another advantage of non-destructive testing is with a you can able to measure all type of properties like chemical, physical, mechanical, all things can be studied by using a non-destructive testing. But whereas in destructive testing, you can, for example, if you see in Rockwell hardness test, you cannot measure impact. In impact test, you cannot measure hardness of the material. Similarly, the stress strain cannot be studied using Rockwell or Brinell hardness test. But whereas in this on a single particular material, you can study what kind of any kind of test can be carried out. That by using a simple technique, that is NDT. But the different that is a different case, that what kind of technique has to be used for what type of study, that is a different case. But overall, if you see, the non-destructive testing can give you a number of results. Okay, so that is the main important thing of non-destructive testing. Keep this in mind. We'll have a next lecture on this, especially on unit 1, that is liquid penetrating testing. What is the we will discuss in next class what are the advantages of it, how it is happening, what are the characteristics, what are the things, how we are going to study those surfaces, that we are going to see in the next lecture. Thank you.